brought to you by Thomas Allgaier and Frennis. This edition highlights key LinkedIn posts on electrification and battery technology in weeks 40 and 41. Frennis supports automotive enterprises and consultancies with market and competitive intelligence, so product teams and strategy leaders do have the optimal base for their strategic decisions. Welcome to the deep dive. Look, if you're anywhere in the mobility world right now, maybe planning charging networks, maybe shaping OEM strategy, these last couple of weeks felt significant. A lot going on.
Yeah, absolutely intense. We've sifted through the noise, really digging into the key electrification and battery tech trends from LinkedIn. We're zeroing in on, I think, two massive shifts.
Okay, what are they?
First, how the EV is becoming, well, basically a power plant on wheels. And second, this looming question around ultra-long-range batteries and what they mean for everything else.
Right, the strategic implications. Right. Okay, so our aim here is to give you that sharp analytical briefing. We're skipping the 101 stuff and getting straight into the big questions shaping the next decade.
Let's do it.
So first up, this fundamental change in how we even think about an EV. It's not just about getting from A to B anymore, is it? The vehicle is being woven into the energy grid. Vehicle to everything, V2X. It feels like a complete repositioning.
That's exactly it. It's the core idea we saw echoed by people like Shucho. Bidirectional charging. It's not just a feature. It's framed as the game-changing tech. Allows power to flow both ways.
So V2H for your house, V2G back to the grid.
Exactly. Vehicle to home, vehicle to grid, maybe selling power back, and even vehicle to load, V2L, powering tools or equipment directly from the car.
And the why behind this seems pretty compelling. Benefits for everyone, really.
Well, yeah. Cost savings potentially for the owner, much needed stability for the grid, especially at peak times, and crucially, it helps soak up all that variable renewable energy we're bringing online.
And the OEMs, they seem to be putting serious money behind this now.
Oh, definitely. Look at Mercedes-Benz. They showed off their ELF, the experimental charging vehicle. We saw posts from Martin Salomon, Marcus Schaefer, Ola Kalanias all highlighting it.
Right, the mobile lab.
Yeah, and it's not just about charging speed, though it's testing 900 kilowatts CCS and looking at MCS. Right. The key is it also integrates V2H, V2G, and V2L. It's the whole package.
A future-proof power hub on wheels. And this idea, it turns the car from just a cost, something that depreciates, into potentially a financial asset.
Precisely. Mercedes is even suggesting smart charging using these systems could save drivers around €500 a year. That starts to sound really interesting to the average person, doesn't it?
It absolutely does. And it's not just concepts. We're seeing actual deployment plans.
Yeah, Manfred Pritzabel has shared news from Switzerland, Ambibox, Helion Energy, and AM Group working together. They're aiming for a series launch in 2026.
Okay, so that's moving fast.
And in the U.S., Jody Verbuman highlighted Honda working with Southern California Edison. They're piloting V2X with the Acura RSX specifically to help grid flexibility.
But the really tangible bit for many people might be vehicle to home, right? Powering your house.
Definitely. Peter Harpin pointed to GM's Energy Home system, using vehicles like the GMC Sierra EV truck to literally keep the lights on at home. That's real energy security.
And we saw some great real-world data on this, too.
We did. Ukas Lewandowski shared his own V2H test. He used his Geely EX5, powered his house for over 7 hours straight.
Wow.
Yeah, delivered nearly 10 kilowatt. That's not a simulation. That's actual blackout protection from your car.
The market is definitely signaling this is coming, and policy seems to be trying to keep up.
It is. Porsche already mentioned funding in Australia for V2G projects, calling it a trifecta for the energy transition. And in Germany, the regulators are actually adapting the rules so households can use storage and bidirectional charging. It's empowering consumers.
So it's moving from a cool tech feature to basically a policy must-have.
Seems that way. It's becoming embedded in the energy system planning. Okay, so if vehicles are becoming these energy hubs, the network needs to handle it, right?
Yeah.
That brings us to the infrastructure piece. The focus now feels very much on, well, the operational reality. Compliance, reliability, and just sheer power delivery, getting the networks ready for scale and making sure they actually work.
Let's start with compliance. That sounds complicated.
It is. Dimitri Develers from FlexCharge really drove this home for Germany. Grid compliance there is mandatory, Section 14A ENWG. But the nightmare isn't the law itself.
And it's the implementation.
Exactly. You've got over 850 different local grid operators, DNOs, and they all kind of define their own specific rules. Imagine trying to deploy chargers nationally with that fragmentation.
Wow. 850 sets of rules.
Yeah. So von Gabriel Huysmos confirmed, basically across Germany, Austria, Switzerland, the DACH region proving you can control the charging load, proving controllability. That's becoming the hurdle you have to clear before you can even switch a site on.
So you need to plan for grid operator control right from the start.
Pretty much. It's essential to avoid overloading local grids.
Okay, moving from compliance to just making sure the chargers actually work. Reliability.
Sam Rawson flagged the UK government's target 99% uptime for public chargers.
That sounds incredibly high.
It is, because most operators, even good ones, are probably around 97%, maybe 98%. Closing that last gap from 97 to 99, it's disproportionately expensive. Redundancy, faster maintenance, it costs a lot.
But you need that reliability for driver confidence, right?
Absolutely. Without it, the whole system falters. It's interesting to contrast with the U.S. approach.
How so?
Angela E. laid out the NEVI playbook. They're mandating open standards, OCPP 2.0.1, OCPI 2.2.1, ISO 151 and 18. The goal is interoperability, making sure different hardware and software talk to each other.
Okay, and their uptime target?
Slightly lower, actually 97%. But crucially, they also mandate capacity. At least 4 DC fast ports, each delivering 150 kilowatts simultaneously. The focus seems more on ensuring usable power is actually there when you need it.
Accessible power, not just theoretical uptime. Got it. Now, what about sheer speed, megawatt charging?
Yep, MCS is moving fast, especially for trucks and fleets.
We saw Sandra Sommer announce the Siemens Charge Flex system. Modular power up to 1.68 mW. That's serious juice.
It really is. And Danilo Baioni detailed Stobley's MCS connector, which they're pushing even further up to 3 mW, 3,000 amps. They're really focusing on the heavy-duty side.
Yeah.
Trucks, buses, even things like ferries.
And the tech seems to be pushing boundaries constantly. Felix Hammer shared that ZRU hit a 1,321 kilowatt peak charge rate in Hangzhou.
Incredible speeds. So the charging tech itself is clearly capable. The bottleneck is more the grid integration, the standardization, making it all work together reliably.
And speaking of integration, EVs are already helping the grid, aren't they?
They are. Jack Berger shared a fascinating stat from the UK. UK power networks procured flexibility capacity to manage grid stress. And 63% of it came from EV charging points.
63%?
Yeah. It shows EVs are actively preventing local grid bottlenecks today, not just a future concept.
Okay, one last piece on infrastructure, the user experience.
Yeah.
Because multiple apps, payment issues, it's still messy.
It can be. Alan Neese highlighted a good example from Malaysia. P&G eWallet is tackling that app chaos. They've integrated over 10 different charging networks into one single mini app.
Simple cashless payment across networks.
Exactly. And it simplifies things like cross-border charging into Singapore, too. That kind of focus on just making it easy for the driver.
Yeah.
That's essential for adoption.
Yeah.
Vendor-agnostic access.
Makes sense. Okay, let's shift gears a bit. Look beyond the immediate infrastructure build-out. So we're building all this infrastructure, V2X is coming. But are we building it for today's EVs or for what's coming down the pike in, say, 2028? This gets into geopolitics, OEM strategy, battery research.
Absolutely. And geopolitics is casting a huge shadow over the supply chain. Rob Anstey's post on China's new export controls was really insightful.
What was the takeaway?
The message seems clear. China doesn't just want to sell the battery cells. They want to own the whole value chain, sell the advanced EVs, the robots that build them, everything using the cells.
So moving up the value chain, not just supplying components.
Right. And that's a direct challenge to Western manufacturing. It really ups the pressure to secure their own technology access and accelerate investment.
That pressure must create some internal tension, especially for legacy automakers.
Definitely. Phil Brash wrote about this, calling it German angst among German car makers like BMW, VW, Porsche.
German angst.
Yeah, this idea that they showcase amazing EVs, world-class EVs, but at the same time, they lobby to keep selling combustion engines for longer, calling it technology openness.
So hedging their bets?
Rash frames it as maybe risk-averse, a fear of going all in on electric because the investment is just so massive. But then you had Wolf Schlachter pushing back strongly.
What was his counterpoint?
His argument was basically, for the European auto industry, the only viable path forward now is electric. He argued that talk about alternatives like hydrogen for passenger cars, that debate is essentially over. The economics just don't stack up anymore.
Okay, so a clear split in perspective there. But this brings us to the potential game changer, future battery tech.
This is where the strategic risk for all that infrastructure investment becomes really clear. Tobias Henmark highlighted the potential disruption from solid-state batteries.
Toyota's plans.
Yeah, exactly. They're targeting a 2027-2028 launch and the promised range, 1,200 kilometers. That's over 750 miles.
750 miles. Okay. What does that do to the charging landscape we just talked about?
Well, think about it. If your average car can go that far, most people could probably cover their entire week's driving, maybe more, just charging at home overnight or maybe at work.
So public fast charging becomes less necessary, for passenger cars anyway.
Potentially much less necessary. Maybe you only need a rapid charge on very long road trips, once every week or two at most. It fundamentally questions the business case for building out vast networks of expensive, high-speed daytime public chargers, doesn't it?
Yeah, that's a massive strategic question for charge point operators right now. Are they building for a problem that might shrink dramatically?
It's an existential risk they have to factor in.
Yeah.
Meanwhile, we're seeing improvements in current tech extending range too.
Right, like one's battery.
Yeah, Dr. Ng. Eric Prada noted their Gemini dual battery hitting 752 miles in a real-world test.
Yeah.
So long ranges are coming one way or another.
And it's not just about lithium-ion, is it?
No. We're seeing other chemistries emerge or re-emerge. Jan Torjubi pointed out the renaissance of sodium-ion batteries operating at room temperature now.
Which was the old problem, right? They used to need high temps.
Exactly. But now companies like CATL and BYD are actually using this improved sodium-ion tech. It offers a potentially cheaper, more abundant alternative to lithium for some applications without the previous operational drawbacks. So lots of diversification happening in battery R&D.
Okay, fascinating stuff. A lot to track there. If you enjoyed this deep dive, new editions drop every 2 weeks. Also check out our other editions on future mobility and market evolution, next-gen vehicle intelligence, and commercial fleet insights.
Yeah, it really feels like we're in this intense period of building out high-speed charging, developing V2G, but it could all be reshaped pretty fundamentally by these ultra-long-range batteries arriving in just a few years.
So the provocative thought for everyone listening
Is really, are you building infrastructure for today's range anxiety problem? Or are you strategically preparing for a future where, for many drivers, range anxiety simply doesn't exist anymore? It's a crucial question for the whole industry to grapple with right now.
A challenging thought to end on. Thank you for joining our deep dive into electrification and battery technology. We'll see you next time.